At 11:47 on the night of August 28, 1945, Lieutenant Commander Stephen Johnson stood in the conning tower of the American submarine Segundo, watching his radar screen with growing disbelief. The Pacific was quiet. A soft swell rolled beneath the hull. The only sounds were the hum of electronics and the distant throb of diesel engines pushing the Segundo through the darkness at 12 knots. 13 days had passed since Japan announced its surrender. The war was over. American sailors were already dreaming of home. Then the radar operator called out a contact bearing 045 degrees, range 12,000 yards. Johnson leaned over the screen and felt his stomach tighten. The contact made no sense. The radar return was too large for a submarine. Much too large. The blip on the screen suggested a vessel the size of a destroyer. But a destroyer would have multiple contacts, escort ships, a formation pattern. This contact was alone. Johnson had spent the war hunting Japanese submarines. He knew their signatures, their capabilities, their limitations. The largest submarines in the Imperial Japanese Navy displaced around 2,500 tons. This contact suggested something twice that size, something that should not exist. Johnson ordered his crew to battle station. The Segundo was a Balao-class submarine, 311 feet long, displacing 2,400 tons submerged. She was one of the most advanced submarines in the American fleet. But as the Segundo closed on the contact, Johnson realized he was approaching something that dwarfed his own vessel. The shape emerging from the darkness was not a destroyer. It was a submarine larger than anything the United States Navy had ever built. What Johnson encountered that night would remain classified for decades. The vessel carried technology that American engineers had never imagined. It represented a weapon system so advanced that the United States would sink it to the bottom of the Pacific rather than let another nation learn its secrets. This is the story of the largest submarine of the Second World War, a vessel designed to strike the American mainland from the sea. A weapon that came within hours of changing the course of history. The idea began in the mind of one man 3 weeks after Pearl Harbor. Admiral Isoroku Yamamoto was 57 years old in January 1942. He had lost 2 fingers at the Battle of Tsushima during the Russo-Japanese War in 1905. Shrapnel scars marked his abdomen. He walked with the slight stiffness of a man who had known combat firsthand. Yamamoto was the architect of the December 7th attack on Pearl Harbor. He had planned it, overseen its execution, and watched the report come in as American battleships burned and sank at their moorings. The operation had been a tactical masterpiece, but Yamamoto knew something that few of his fellow officers understood. He had studied at Harvard University from 1919 to 1921. He had served twice as naval attaché in Washington, learning to play poker and to speak English. He had traveled across America, visited factories, observed the production lines that could turn out automobiles and appliances in numbers that Japan could never match. He understood American industrial capacity better than almost any officer in the Imperial Japanese Navy, and he knew that Japan had awakened a sleeping giant. In the weeks after Pearl Harbor, while Japanese forces swept across Southeast Asia and the Pacific, Yamamoto calculated the mathematics of attrition. America had lost battleships, yes, but American shipyards were already laying keels for new vessels. By 1943, America would be producing aircraft carriers faster than Japan could sink them. By 1944, the balance of power would shift irrevocably. By 1945, Japan would face annihilation. Yamamoto needed a weapon that could strike America before the industrial tide became overwhelming, not aircraft carriers, which Japan could not replace as quickly as America could build them, not battleships, which required enormous resources to construct and maintain. Something unexpected, something that America could not anticipate or counter. Submarines. But not ordinary submarines. Yamamoto envisioned underwater aircraft carriers, vessels large enough to cross any ocean on Earth, submarines that could surface off the coast of New York or San Francisco, launch bombers, and disappear beneath the waves before any defender could respond. On January 13, 1942, Yamamoto submitted his proposal to Fleet Headquarters. He requested 18 massive submarines, each capable of carrying multiple attack aircraft. Each submarine would have the range to circle the globe 1.5 times without refueling. Each would carry enough fuel, food, and ammunition to remain at sea for 4 months. The proposal was ambitious beyond anything the world had seen. The largest American fleet submarine displaced 2,400 tons. Yamamoto wanted submarines displacing over 6,000 tons. The technology to build such vessels did not exist. The engineering challenges seemed insurmountable. But Japan was desperate, and desperate nations attempt the impossible. Captain Kameto Kuroshima led the feasibility study. He was known throughout the fleet as a brilliant but eccentric officer whose analytical methods and tactical insights had earned Admiral Yamamoto's trust. His analysis was thorough and unsparing. By March 17, 1942, general design plans were complete. The submarines would be 400 feet long, nearly 100 feet longer than any American submarine. They would be 39 feet wide, almost twice as wide as conventional vessels. Their draft, the distance from the waterline to the bottom of the keel, would be 23 feet. They would displace 5,900 tons on the surface and 6,500 tons submerged, more than double the displacement of American fleet submarines. The design required revolutionary engineering. A conventional submarine hull could not support the weight of an aircraft hangar on its deck. So the engineers developed a double hull design with 2 parallel pressure cylinders joined in a figure 8 cross-section, providing the structural strength necessary to carry the massive superstructure. This innovation would influence submarine design for decades. That hangar would be the heart of the design. 115 feet long, 11 feet in diameter, constructed of steel thick enough to withstand the crushing pressure at 330 feet below the surface, sealed with a 2-inch thick rubber gasket, capable of opening hydraulically from inside when the submarine surfaced. Inside that cylinder, 3 attack aircraft would be stored, their wings folded, their tail collapsed, waiting for the moment they would be unleashed against an unsuspecting target. 4 diesel engines generating a combined 9,000 horsepower would propel the submarine at nearly 19 knots on the surface. 2 electric motors providing 4,200 horsepower would push the vessel at 6.5 knots submerged. The fuel tanks would hold enough diesel to travel 37,500 nautical miles, 1.5 times around the Earth without refueling. The aircraft themselves required a new design. Aichi Aircraft Company received the contract in May 1942. The specifications seemed impossible. The aircraft had to fit inside a cylinder 11 feet in diameter. It had to be powerful enough to carry heavy ordnance. It had to be fast enough to survive against enemy fighters. It had to be capable of water landings for recovery by the submarine. Aichi's engineers spent months developing solutions. Their final design, designated M601 Seiran, which translates to mountain haze, was a masterpiece of compact engineering, a 2-seat low-wing monoplane powered by a 1,400 horsepower Aichi Atsuta engine, itself a license-built copy of the German Daimler-Benz DB601. The engine drove a 3-blade propeller and could push the aircraft to 295 miles per hour, comparable to many land-based fighters. The Seiran could carry an 1,800-pound bomb under the fuselage or a Type 91 aerial torpedo. A single 13mm machine gun mounted on a flexible rear-facing mount provided defensive armament. The aircraft had a range of 740 miles, enough to strike targets far inland and return to the submarine. But the true innovation was in the folding mechanism. The Seiran's wings rotated 90 degrees and folded hydraulically again. The fuselage, reducing the wingspan from 40 feet to just under 12, the horizontal stabilizers collapsed downward. The top portion of the vertical stabilizer folded as well. The detachable twin floats were stored in separate compartments beside the hangar. Assembly points were coated with fluorescent paint to allow crews to work in darkness. A crew of 4 trained men could roll a Seiran out of the hangar on a collapsible carriage, attach the floats, unfold the wings and tail, and prepare the aircraft for launch in approximately 7 minutes. The engine presented a particular challenge. Aircraft engines normally require warm-up time before flight, but a surfaced submarine was vulnerable to detection. Every minute on the surface increased the risk. So the engineers developed a system to preheat the engine oil to 140 degrees Fahrenheit in a separate chamber inside the submarine. Just before launch, The hot oil and hot water were pumped through the engine while the aircraft was still in the hangar. The Siren would be catapulted from a cold start with its engine already at operating temperature. It was a dangerous procedure, but it allowed all three aircraft to be launched within 45 minutes of surfacing. Only 28 Seirans were ever built, including 8 prototypes. A land-based trainer version called Nanzan, meaning Southern Mountain, was developed to help pilots learn the aircraft without risking the precious floatplanes. But shortages of materials and labor meant that even these small numbers were difficult to achieve. Construction began on January 18, 1943. At the Curie Naval Arsenal. The I-400 was laid down as submarine number 5231. Workers labored around the clock in the massive shipyard, their welding torches casting flickering shadows on the growing hull. The vessel was so large that special cranes had to be constructed to lift sections into place. Allied bombing raids grew more frequent as the months passed. American B-29 bombers struck industrial targets across Japan. The shipyard workers learned to scatter when the air raid sirens wailed, seeking shelter in the concrete bunkers that dotted the facility. Then they returned to work, often finding their equipment damaged, their materials scattered, their progress set back by hours or days. Steel shortages forced compromises. Japan's merchant fleet was being decimated by American submarines, the very weapon Japan had once dominated. Shipments of raw materials from occupied territories slowed to a trickle. The quality of steel declined as impurities increased. Workers had to reject more and more material as unsuitable. Labor shortages meant that schoolgirls as young as 12 worked in the shipyards and aircraft factories. These children, called volunteer workers, handled rivets, sorted parts, and performed tasks that freed adult workers for more complex operations. They worked long hours in conditions that would have been considered unsafe, even by wartime standards. An earthquake near Nagoya on December 7, 1944, damaged the Aichi factory and delayed production of the Siren aircraft. American air raids on March 12, 1945, struck the same facility again. Production schedules that were already impossible to meet slipped further behind. Originally, 18 submarines were planned. Yamamoto's vision called for a fleet of underwater aircraft carriers that could strike any target on Earth. But reality intervened at every step. The number was reduced to 9 after Yamamoto's death, then to 5 as steel and labor shortages mounted. Finally, only 3 would be completed before the war ended. A fourth, the I-404, was 90% complete when construction was halted in March 1945. A fifth was converted to a fuel tanker, because Japan needed oil more than it needed another aircraft carrier. 13 planned vessels were cancelled before construction even began. Admiral Yamamoto never saw his vision realized. On April 14, 1943, American radio intercept stations copied an encrypted Japanese naval message. Codebreakers at the Fleet Radio Unit Pacific at Pearl Harbor, working with their counterparts in Washington, spent hours deciphering the transmission. What they found was extraordinary. The message contained a detailed itinerary for Admiral Yamamoto, commander of the combined fleet, the most important naval officer in Japan. Yamamoto was planning an inspection tour of Japanese bases near Bougainville in the Solomon Islands. His schedule was precise, timed to the minute. He would depart Rabaul at 600 hours on April 18th aboard a Mitsubishi G4M bomber, escorted by 6 Neuro-fighters. He would arrive at Balalay Airfield at 7:45. Admiral Chester Nimitz, commander of the Pacific Fleet, faced a decision. The information was invaluable, but using it risked revealing that America had broken Japanese codes. If Yamamoto's aircraft was shot down, the Japanese might realize their communications were compromised. They might change their encryption systems. The intelligence advantage that had helped win the Battle of Midway might be lost. Nimitz consulted with Admiral William Halsey, commander of South Pacific Forces. Both men understood what Yamamoto meant to Japan. He was the architect of Pearl Harbor. He was the most experienced and innovative naval strategist in the Japanese fleet. His death would be a blow to Japanese morale that could not be measured in ships or aircraft. Nimitz authorized the mission. On April 18, 1943, exactly 1 year after the Doolittle raid on Tokyo, 18P30. 8 Lightning fighters from the 339 Fighter Squadron took off from Henderson Field on Guadalcanal. Major John Mitchell led the formation. They flew at wave top level for over 2 hours, navigating by dead reckoning, maintaining radio silence, circling around the Solomon Islands to avoid detection. They reached the interception point on time. 2 bombers appeared, escorted by 6 Neros. The American fighters attacked. Captain Thomas Lamphere and Lieutenant Rex Barber dove on the bombers while the cover flight engaged the escorts. Yamamoto's aircraft went down in the jungle. His chief of staff, Vice Admiral Matome Yugaki, survived the crash of the second bomber into the sea. Japanese search parties found Yamamoto's body still strapped to his seat, thrown from the aircraft but still clutching his samurai sword. An autopsy found 2 bullet wounds. He was 59 years old. The guiding hand behind the I-400 program was gone, but the submarines continued to take shape in the shipyards of Kure and Sasebo, built by workers who did not know that the admiral who had conceived their mission would never see them completed. The I-400 was commissioned on December 30th, 1944. Commander Toshio Kusaka assumed command. He was an experienced submarine officer who had previously commanded the I-26, the I-174, and the I-180. He understood the capabilities and limitations of undersea warfare, but nothing in his experience had prepared him for a vessel like the I-400. The submarine was a floating city. 144 officers and enlisted men lived aboard during operation. The vessel carried 20 Type 95 torpedoes for its 8 forward torpedo tubes. A 5.5-inch deck gun sat aft of the hangar. 3 triple-mounted 25mm anti-aircraft guns protected against air attack. Radar systems, both air search and surface search, provided early warning. Demagnetization cables ran along the hull to protect against magnetic mines. An anechoic coating absorbed sonar pulses to reduce the submarine's acoustic signature. But the I-400 had weaknesses that Kusaka understood immediately. The massive hangar and offset conning tower created a significant radar signature on the surface. The submarine took 56 seconds to dive, nearly double the time required by American fleet submarines. When submerged at slow speed, the offset superstructure forced the helmsman to steer 7 degrees to starboard just to maintain a straight course. The vessel was difficult to maneuver in combat. The I-400 was not designed for submarine warfare. It was designed to deliver aircraft, and the target for those aircraft was the Panama Canal. The Panama Canal was the jugular vein of American logistics. Ships carrying men and supplies from the Atlantic to the Pacific entered the canal at Colon on the Caribbean coast. They passed through the Gatun Locks, a triple flight that raised vessels 86 feet to the level of Gatun Lake. They crossed the lake, transited the Culebra Cut through the Continental Divide, descended through the Pedro Miguel and Miraflores locks, and emerged at Panama City on the Pacific side. The transit took approximately 8 hours. Without it, ships would have to sail around Cape Horn at the tip of South America, adding over 8,000 miles and weeks of transit time to every voyage. The canal was heavily defended. Fort Sherman on the Atlantic side mounted coastal artillery batteries with a range of 70 miles, preventing enemy ships from approaching close enough to shell the locks. Fort Amador on the Pacific side provided similar protection. Barrage balloons floated over the lock structures. Anti-submarine nets guarded both entrances. The 88th Coast Artillery Regiment manned anti-aircraft positions. Fighter aircraft patrolled from bases on both sides of the isthmus. But the defenses were designed against conventional attack. A surface fleet approaching from the sea, bombers flying from distant bases with time to be detected and intercepted. No one had considered that an attack might come from submarines carrying aircraft. In August 1943, Captain Chikao Yamamoto, no relation to the admiral, and Commander Yasuo Fujimori conceived the plan. A Japanese engineer who had worked on the canal during its construction provided invaluable intelligence. He handed over hundreds of documents, including blueprints of the lock structures, specifications for the lock gates, descriptions of the construction methods used. Japanese shipping engineers studied the materials for months. Their analysis identified vulnerabilities. The lock gates at Miraflores on the Pacific side were accessible, but their destruction would cause limited damage. The Gatun locks on the Atlantic side offered a more tempting target. Behind those locks lay Gatun Lake, the artificial body of water that ships crossed during their transit. The lake was held in place by the Gatun Dam and the locks themselves. If the lock gates were breached, the water of Gatun Lake would drain into the Caribbean. The canal would be completely inoperable until the gates were repaired and the lake refilled. Intelligence analysts estimated the canal would be unusable for at least 6 months. The attack plan called for 4 submarines. The I-400 and I-401 would each carry 3 Syren aircraft. 2 smaller vessels, the I-13 and I-14, were modified to carry 2 Syrens each. 10 aircraft in total. They would sail eastward across the Pacific to a point 100 miles off the coast of Ecuador. At 3 in the morning on a moonlit night, the submarines would surface and launch their aircraft. The Syrens would be painted with American markings to confuse defenders. They would fly northeast over Colombia, turn west over the Caribbean, and approach the canal from the Atlantic side at dawn. The pilots would dive on the Gatun locks and release their bomb. After the attack, they would ditch their aircraft near the submarines and be recovered by the waiting vessels. Training began in June 1945 at Nana Bay on the western coast of Honshu. The location was chosen for its isolation from American air attacks and its sheltered waters. All 4 submarines of Submarine Division 1, the R-400, I-401, I-13, and I-14, gathered there by June 5th. 6 Syren aircraft of the 631 Naval Air Group flew in from Kure. The Maizuru Naval Arsenal constructed a full-scale wooden mock-up. The Gatun locks, placed it on a raft, and towed it into the bay. The mock-up reproduced the dimensions of the actual lock gates, the angles of approach, the distances that pilots would need to judge during their attack runs. Pilots practiced rapid assembly of their aircraft, night catapult launches, and bombing runs against the mock-up. The training revealed problems that could not be easily solved. Torpedo bombing required precise timing, steady hands, and extensive practice. Only one pilot, Lieutenant Takashi, truly mastered the technique. The others could deliver bombs accurately but struggled with the more complex torpedo attacks. Eventually, the plan was modified to rely primarily on bomb attacks rather than torpedoes. Catapult launches were dangerous in any condition. In rough seas, they became potentially fatal. The submarines pitching and rolling made timing critical. Pilots had to be launched at the precise moment when the deck was level. A mistimed launch could send an aircraft into the water before it gained flying speed. The navigator had to coordinate with the catapult crew watching the submarine's motion, calling out the moment to fire. Lieutenant Atsushi Asamura, one of the Syren pilots, later recalled the difficulty. The compressed air catapult was smoother than gunpowder systems used on other vessels, but launching against the wind was essential for the aircraft to gain enough lift. If the wind direction changed during a catapult launch, the results could be catastrophic. Night operations presented additional challenges. The submarines would need to surface, launch their aircraft, and dive again before dawn revealed their position to enemy patrols. Every step had to be performed in darkness or under minimal lighting. The fluorescent paint on the Syren's assembly points helped, but crews still fumbled with unfamiliar equipment in the confusion of night operation. One Syren failed to return from a training flight on June 19th. The aircraft simply vanished. The bodies of its 2 crew members, their names now lost to history, washed ashore on Sadagashima Island days later. The cause of the crash was never determined. By June 20th, 1945, training was complete. The crews had achieved the best proficiency that time and resources allowed. The operation was ready to proceed. The submarines would sail within days to strike the Panama Canal and change the course of the war. Then Okinawa fell. The fall of Okinawa changed everything. American forces were now within striking distance of the Japanese home islands. The Panama Canal operation, which might have delayed American logistics for months, would have no impact on the coming invasion. The Imperial Japanese Navy General Staff cancelled the attack. Instead, the submarines received new orders. They would attack the American fleet anchorage at Ulithi Atoll in the Caroline Islands. Ulithi was the staging point for American air raids against Japan. Dozens of aircraft carriers, battleships, and supply vessels anchored there between operations. A successful strike could destroy ships and aircraft preparing for the invasion of Japan. The plan was desperate. The pilots would not ditch and be recovered. They would fly one-way missions, kamikaze attacks. On July 18, 1945, a farewell ceremony was held at the Shirato Inn in Maizuru. Vice Admiral Tadashige Daigo, Commander-in-Chief of the 6th Fleet, raised a sake toast to the pilots of the 631 Naval Air Group. Captain Tatsunosuke Arizumi, Commander of Submarine Division 1, presented ritual short swords to the air crews. Captain Arizumi was a controversial figure. He had commanded the submarine I-8 earlier in the war. During that command, he had ordered the execution of survivors from ships his submarine had sunk. On March 26, 1944, His crew massacred 98 survivors of the Dutch merchant ship Giselak in the Indian Ocean. Arizumi personally executed several of the ship's officers. The British called him the Butcher. Now, Arizumi commanded the largest submarines ever built, carrying pilots who would sacrifice their lives for a dying empire. The I-400 departed Ominato at 1400 hours on July 23rd. The I-401 followed 2 hours later, with Captain Arizumi aboard as flotilla commander. The submarines took separate routes across the Pacific to avoid detection, planning to rendezvous south of Panape Island on August 16th before launching the attack on Ulithi. The voyage was a test of endurance and nerves. The submarines traveled mostly submerged during daylight hours to avoid American patrol aircraft. They surfaced at night to recharge their batteries and refresh the air inside the hull. The crews lived in conditions that would have been miserable even for experienced submariners. The I-400 carried 144 men in a space designed for efficiency rather than comfort. Bunks were stacked 3 high. The air grew stale quickly when submerged. Temperatures in tropical waters rose to unbearable levels. Unlike American submarines, which had air conditioning to control interior temperatures, Japanese boats offered no such luxury. Men sweated through their watches, their uniforms soaked, their concentration frayed by the oppressive heat. The toilets were primitive by any standard. Japanese submarines of this era did not have flush toilets. Waste had to be disposed of carefully to avoid detection by enemy sonar. The smell inside the hull was a constant presence that veterans described in terms that cannot be repeated in polite company. Food was another challenge. The submarines carried provisions for 4 months. Rice, dried fish, preserved vegetables, and canned goods formed the basis of every meal. Fresh food was consumed first, and then forgotten. The monotony of the diet matched the monotony of the voyage. Endless days of waiting, punctuated by moments of terror when enemy contacts appeared on sonar. The voyage was plagued with difficulties beyond the ordinary hardships of submarine operation. On July 23rd, just hours after departure, the I-401 passed through the Tsugaru Strait between Honshu and Hokkaido. 2 Japanese Army coastal artillery batteries on the Hokkaido shore mistook her for an enemy submarine and opened fire. Type 96 150mm howitzer shells crashed into the water around the submarine. One landed 300 meters off the port quarter, close enough to spray the deck with seawater. Arizumi ordered an emergency dive. The submarine plunged beneath the surface while confused radio messages flew between naval and army commands. The friendly fire incident could have ended the mission before it began. When the I-401 surfaced after exiting the strait, Arizumi transmitted an angry protest to naval headquarters. A typhoon struck on July 28th and 29th. The massive submarines rode the storm better than smaller vessels would have. Their double hull construction provided stability, their size giving the inertia against the rolling seas. But the delay threw off their carefully calculated schedule. Time that should have been spent traveling toward the target was lost riding out the storm. On August 5th, the I-400 suffered an electrical fire in a portside control panel. Smoke filled the compartment. Commander Kusaka ordered an emergency surface, the submarine breaching the wave. In a maneuver that would have revealed her position to any watching aircraft, his lookouts spotted an American convoy in the distance. Grey shapes on the horizon that could have spelled doom for the mission. Kusaka ordered a crash dive. The submarine descended rapidly, trailing smoke from her still smoldering electrical systems. For 5 hours, the I-400 sat just below the surface while engineers worked frantically to repair the damage. The crew waited in stifling heat, smoke burning their eyes and lungs, listening for the splash of depth charges that never came. The convoy passed without detecting them. The submarines pressed on toward their rendezvous. Arizumi changed the meeting point multiple times as American air and surface activity increased near the original location. Radio transmissions were kept to a minimum to avoid detection, but each change of plan required communication. On August 14th, he transmitted new coordinates to the I-400, ordering the submarine to meet at a point 100 nautical miles south of Panap. The message was never received. The I-400, her communications equipment damaged in the electrical fire, continued toward the original rendezvous point. The 2 submarines that were supposed to attack together would not find each other. That same day, the situation in Japan had changed forever. The first atomic bomb had fallen on Hiroshima on August 6th. The second had destroyed Nagasaki on August 9th. Emperor Hirohito announced Japan's surrender on August 15th. The crews of the submarines did not believe the announcement. For days, conflicting orders arrived from Tokyo. One message confirmed that peace had been declared. Another ordered all submarines to execute predetermined missions and attack the enemy if discovered. Arizumi initially chose to continue the attack, but on August 18th, at 2100 hours, the Sixth Fleet transmitted explicit orders to cancel the operation. The submarines were to return to Kure and surrender. The pilots of the 631 Naval Air Group would not fly their final mission, but they would not allow their aircraft to fall into enemy hands. On August 22nd, the crews of the I-400 and I-401 assembled their Siren aircraft on deck. The planes were still painted with American markings from the planned deception operation. One by one, the bombers were rolled onto the catapult and launched unmanned into the sea, wings unfolded, propellers spinning. Empty cockpits. The aircraft climbed briefly, stalled, and plunged into the Pacific. The torpedoes were fired without arming. The bombs were dumped overboard. The codes, logs, and charts were destroyed. Everything that could reveal the submarine's capabilities was eliminated. The I-400 hoisted the black flag of surrender on August 27th. American destroyers Blue and Mansfield intercepted her 500 miles northeast of Tokyo at noon. The sailors on the destroyer stared in disbelief at the vessel before them. The submarine was nearly as long as the Blue, and just as wide. The massive hangar dominated the deck. A catapult stretched along the forward section. A crane protruded from the structure. Nothing in their experience had prepared them for what they were seeing. The Americans had believed they knew everything about Japanese submarine technology. They had captured vessels, studied wreckage, interrogated prisoners. But they had never heard of anything like the I-400. The existence of the submarine aircraft carrier program had remained a closely guarded secret throughout the war. A prize crew from the destroyer Escort Weaver, led by Commander Hiram Cassidy, boarded the I-400 on August 28th. Cassidy was a veteran submarine officer who had commanded the Sea Raven and the Tigrone. He had spent years studying submarine design and capabilities. Even he was astonished by what he found. The massive hangar could have held a small aircraft factory. The catapult system was more sophisticated than anything the Americans had developed. The crane for recovering aircraft demonstrated engineering solutions that American designers had never attempted. The anechoic coating on the hull, designed to absorb sonar pulses, represented technology that America was only beginning to explore. The snorkel system, allowing the submarine to run its diesel engines while submerged, was more advanced than German designs that American engineers had studied after the fall of the Third Reich. The I-400's crew had destroyed what they could, but the vessel itself remained intact, and it represented a technological prize of incalculable value. 2 days later, Lieutenant Commander Johnson and the Segundo encountered the I-401 under similar circumstances. Johnson's first conversation with Lieutenant Muneo Bando, the Japanese navigation officer who negotiated the surrender, was conducted in what Johnson later described as baby talk plus violent gestures. Bando claimed the submarine carried 200 men. Johnson assumed this was a translation error. It was not. Captain Arizumi did not surrender. As the I-401 sailed toward Tokyo Bay under American control, Arizumi retreated to his cabin. On August 30th, in the Philippine Sea off Izuoshima, he placed a pistol in his mouth and pulled the trigger. His crew wrapped his body in a Japanese flag and disposed of it through a hatch without the Americans noticing. Arizumi knew that his war crimes would be prosecuted. He chose death over judgment. The American flag was raised over the I-401 at 500 hours on August 31st, 1945. Lieutenant Commander Nobukio Nambu presented 2 samurai swords to Lieutenant J. Wilson as symbols of surrender. The largest submarines ever built had fallen into American hands without firing a shot in anger. On September 2nd, as the formal surrender ceremony took place aboard the battleship Missouri in Tokyo Bay, Vice Admiral Charles Lockwood, commander of Submarine Force Pacific Fleet, ordered his person flag hoisted aboard both the I-400 and I-401. It was a symbolic gesture. The American submarine force had captured the most advanced undersea vessels in the world. The Americans studied the submarines intensively. Engineers examined every system, photographed every component, documented every innovation. The aircraft hangar's construction methods were analyzed in detail. The catapult system was tested and measured. The snorkel, which allowed diesel engines to operate while the submarine remained just below the surface, was studied as a potential addition to American designs. The anechoic coating was scraped and analyzed in laboratories. The double-hull design attracted particular attention. No American or German submarine used this configuration. The Figure 8 cross-section provided structural strength that conventional single-hull designs could not match. Some historians have speculated that Soviet submarine designers may have drawn inspiration from similar concepts when developing their Typhoon-class ballistic missile submarines in the 1980s, though direct influence remains unconfirmed. The concept of submarine-launched aircraft, while impractical for conventional bombers, would evolve into submarine-launched missiles that became the backbone of nuclear deterrence during the Cold War. But the Americans also faced a problem that grew more urgent with each passing month. The Soviet Union demanded access to the captured submarines. Under the terms of the Potsdam Agreement that ended the war, Japan's military equipment was to be divided among the Allied powers. Soviet engineers wanted to examine the same technology that American engineers were studying. Soviet naval intelligence had heard rumors of the massive submarines and wanted to see them firsthand. American commanders recognized the threat immediately. The Soviet Union was no longer an ally but an emerging adversary. The Cold War was beginning. Soviet submarine technology lagged behind American and German designs. Access to the I-400 class could accelerate Soviet development by years. The decision was made at the highest levels of the Navy Department. The submarines were too valuable to share. They would be studied thoroughly, and then they would be destroyed. In late 1945, the I-400, I-401, and I-14 were prepared for the voyage to Pearl Harbor. American prize crews of 4 officers and 40 enlisted men were assigned to each vessel. The submarine's Japanese crews remained aboard to operate the complex machinery under American supervision. Japanese motor launches were loaded onto the decks to serve as lifeboats in case of emergency. The flotilla departed Sasebo on December 11, 1945, escorted by the submarine rescue vessel Greenet. The voyage was difficult. The submarines were uncomfortable in rough seas. The offset conning tower and massive hangar made them roll heavily in swells. Many American sailors became seasick. One crew member later complained that the vessel bounced like a cork in rough weather. They stopped at Guam from December 18th to 21st, then at Eniwetok in the Marshall Islands, then at Kwajalein for fuel and supplies on December 26th and 27th. The submarines arrived at Pearl Harbor on January 6th. 1946, greeted by a Navy band and local officials curious to see the legendary vessels. Engineers conducted extensive evaluations over the following months. Every system was examined in detail. Every innovation was documented. Photographs and measurements filled volumes of technical reports. American designers incorporated some of the lessons into plans for future submarines. Then the submarines were destroyed. On May 31st, 1946, the I-401 was towed to deep water off Kalaeloa near Oahu. The submarine Cabazon approached and fired 2 Mark 18 electric torpedoes. The weapons struck the hull. The I-401 sank in 2,300 feet of water, taking her secrets to the ocean floor. On June 4th, the I-400 followed. The submarine Trumpetfish fired 3 Mark 18 Mod 2 torpedoes. Vice Admiral Alan McCann, Commander of Submarine Force Pacific, and Commander Lawson Raj, Commander of Submarine Division 52, observed the sinking from aboard Trumpetfish. They watched the largest submarine of the Second World War slip beneath the waves. The I-402, which had been converted to a fuel tanker and never saw combat, was scuttled off the Goto Islands near Nagasaki in April 1946. The I-14 met the same fate off Oahu on May 28th. The United States Navy officially reported that it had no information on the precise location of the sinkings. The technology would remain hidden from the Soviet Union. For nearly 70 years, the I-400 lay undiscovered in the darkness of the Pacific. The ocean floor southwest of Oahu is a landscape of rocky outcrops, sediment fields, and scattered debris from decades of military operation. Sonar surveys revealed hundreds of anomalies, any one of which could be a shipwreck or simply an unusual geological formation. Distinguishing between them required patient investigation, careful analysis, and the resources to send submersibles to investigate each promising target. The Hawaii Undersea Research Laboratory at the University of Hawaii had been searching for lost submarines since 1992. Using the deep-diving submersibles Pisces 4 and Pisces 5, researchers had located several Japanese midget submarines from the Pearl Harbor attack. They had found the I-401 in 2005, but the I-400 remained elusive. Terry Kirby, operations director at the laboratory, had studied the historical records for decades. He knew the approximate area where the submarine had been scuttled. But approximate was not precise. The ocean floor in that region covered hundreds of square miles. On August 1, 2013, Kirby was piloting Pisces 5 on a maritime heritage dive funded by the National Oceanic and Atmospheric Administration. Dr. James Delgado of the agency's Maritime Heritage Program and Dr. Hans van Tilburg, the Pacific Islands Maritime Heritage Coordinator, were aboard as observers. They were investigating multibeam sonar anomalies identified during previous surveys. The submersible descended through the darkness. At 1,826 feet, the seafloor came into view in the lights. Kirby guided the vessel toward a target that appeared promising on the sonar charts. As they approached, shapes began to emerge from the gloom. Kirby knew immediately that they had found something significant. The aircraft launch ramp was visible, stretching along what remained of the forward deck. The deck crane protruded from the structure. Torpedo tubes were arranged in the distinctive pattern of Japanese submarine design. The vessel was enormous, far larger than any other submarine wreck in Hawaiian waters. The I-400 had been found. Kirby described the moment as a thrill when the view of a giant submarine appeared out of the darkness. The wreck lay partially collapsed from the torpedo impacts that had sunk it nearly 70 years earlier, but the hull was largely intact. The hangar structure that had made the submarine unique remained identifiable. Delgado called the discovery technologically significant. The design features associated with its large watertight hangar represent an important step in the evolution of submarine design. Following the Second World War, submarine experimentation and design changes would continue in this direction, eventually leading to ballistic missile launching capabilities. The discovery was announced in December 2013 after careful coordination with the United States State Department and officials from the Japanese government. The wreck site was protected under federal law as a significant maritime heritage resource. Van Tilburg called it a reminder of critical events and sacrifices. Our ability to interpret these unique weapons of the past and jointly understand our shared history is a mark of our progress from animosity to reconciliation. In March 2016, Pisces 5 returned to the wreck site with a specific mission. The submarine's bell had been located in the debris field during earlier surveys. With a permit from the Naval History and Heritage Command, researchers carefully recovered the bell, lifting it from 547 meters and placing it in a recovery container. The bell, just over 13 inches in diameter at the base, bore a crack, likely caused by the torpedo explosions that had sunk the vessel. The bell now resides at the USS Beaufort Submarine Museum at Pearl Harbor, where it serves as a tangible connection to the largest submarines of the Second World War. Visitors can see the artifact and learn the story of the vessels that were designed to bring destruction to American shores but never fired a shot in anger. A single Aichi Seiran survives. It is displayed at the Smithsonian National Air and Space Museum's Stephen F. Udvar-Hazy Center near Washington. The aircraft was surrendered at the end of the war by Lieutenant Kazuo Akatsuka, who flew it from Fukuyama to Yokosuka. The Navy donated it to the Smithsonian in 1962. Restoration began in 1989 and was completed in 2000. The I-400 class submarines never attacked the Panama Canal. They never struck the American fleet at Ulithi. They never launched a single aircraft against an enemy target. The largest submarines of the Second World War surrendered without accomplishing their mission, but their legacy endures. The concept of projecting air power from beneath the sea evolved into submarine-launched ballistic missiles. The double-hull design influenced later submarine construction. The technology that American engineers studied in 1946 shaped decades of undersea warfare development. Admiral Yamamoto died before his vision was realized. Captain Ariizumi died rather than face judgment for his crimes. Commander Kusuka and Lieutenant Commander Nambu survived the war. The pilots of the 631 Naval Air Group went home to families who never learned how to close. Their sons and husbands came to flying one-way missions against the American fleet. The I-400 rests on the ocean floor near Hawaii, 1,800 feet below the surface. The vessel that was designed to strike America from the sea now lies within sight of the coastline it was meant to attack, a monument to engineering ambition, a reminder of what desperate nations will attempt when facing defeat, and a testament to the secrets that the ocean keeps. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters, each one deserves to be remembered, and we would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories alive.